In these problems, we're being asked to find the areas of regular polygons. And remember, a regular polygon is one in which all the sides have the same lengths, all the angles are the same. So we're talking about squares and regular hexagons and pentagons, and actually any number of sides you want as long as all the sides are the same. This formula is going to work. The formula is 1/2 times the apothem, which may be a new term, and we'll talk about what that is, times the perimeter. So the distance around the outside. The apothem is this line that you see drawn in right here. It's actually a line from the center of an inscribed circle. So if you had a circle here and you go into the exact center and then dropped a line down perpendicular to the side of your regular polygon, you're going to get the apothem. And think about this with a square. So if you've got a square, you've got sides of length s here, and the apothem is going to be 1/2 s. So let's just verify that this formula actually works with a square. We know that the area of a square equals s squared. And if we use this formula, it's 1/2 times the apothem, which is 1/2 times s, times the perimeter, and the perimeter is s plus s plus s plus s, or 4s. And if you put all these together, 1/2 times 1/2 is 1/4 times 4th is 1. That just leaves s times s. That equals s squared. So we can see this formula is working for the area of a square. With a figure like a hexagon, much easier to use this formula. So let's try it here. 1/2 times the apothem times the perimeter. It says one side is 2 inches, so our perimeter is going to be 2 times 6, because this is a hexagon. It's got 6 sides. So that's 12. And the apothem is, well, they give it to us 1.7. So to put in our formula here, we have 1/2 times 1.7 times 12. And that, if you crunch it out, should equal 10.2. And let's see, we're in inches. And this is area, so this is square inches. Let's try another one. Here they don't give us a picture, but it says if a regular hexagon, so again we're dealing with 6 sides, with 4 centimeter sides, has an area of approximately 41.57 square centimeters, what's the length of the apothem? Well, we can figure that out. We know our formula is area equals 1/2 times the apothem times the perimeter. The sides are 4 centimeters and it's a hexagon, so the perimeter is going to be 4 times 6, or 24. We know our area, so we'll plug it in there. 41.57 equals 1/2 of the apothem times 24. And let's see, a quick little bit of arithmetic in my head. 1/2 times 24 is 12, and then I could divide both sides by 12. And what you should get here is 3.46 centimeters. We started in square centimeters for the area. The apothem is just a line, so it's going to be plain old centimeters. All right, let's look at one more. This one's a little bit trickier. It says find the area of a regular hexagon with side 8. It's a hexagon again. It's got side 8, so we know the perimeter is going to be 6 times 8, or 48. That's not tough, but we're not being given the apothem. So here's a trick you should probably know with hexagons, and maybe you know this already. I didn't draw that very regularly, but if you put a dot in the center here, and remember the apothem would be that perpendicular, and then you started drawing lines to all the vertices, what you would get is 6 triangles, and they are all equilateral triangles. If you've got a regular hexagon, it's made up of 6 equilateral triangles. And the side here are 8. So with that information, if we know this triangle is an equilateral and this side is 8, we can figure out what that altitude is there, which is the apothem. Let me just pull that equilateral out here. So we've dropped our line down there, our perpendicular. That cuts this side into 4 and 4. We know this side is 8. So if you wanted to get this side here, you could use the Pythagorean theorem. The other thing you can realize is since this is an equilateral triangle, when you split it in two, you get two 30, 60, 90 triangles. And you might remember that the ratios of the sides are 1, 2, and square root of 3. So all I have to do to get this side is multiply 4 times the square root of 3. So our apothem equals 4 times the square root of 3. If you're not sure where I got that, just use the Pythagorean theorem. A squared plus b squared equals, 4 squared plus b squared equals 8 squared. You'll come out with the same thing. Now, we have the perimeter, we have the apothem, so we're ready to put it in our formula. Area equals 1/2 of the apothem times the perimeter. And let's see, 1/2 times 4 times 48, that's 2 times 48. So the area equals 96 times the square root of 3. And I think for this one, we're just going to leave it in those terms. If you want to punch that out on your calculator and find the decimal, you can certainly do that. So that's a little bit of work with the areas of regular polygons. My name is Larry. I'm a teacher at EdVision's off-campus. It's an online project-based school for 7th through 12th graders. If you're in Minnesota and you want to check us out, you can find us at lovethischool.org. Thanks.